Hello students, welcome to Inside Physics. Today we will see some problems in motion in straight line targeting our JEE mains exam. So here is the first one. Based on the graphical model, here is a problem for you. A particle starts from the origin at t is equal to 0 and moves along the positive x-axis. The graph of velocity time graph is given in the picture. What is the position of the particle at time t is equal to 5 seconds? Here the particle is moving from time t is equal to 0 means it is the starting position. Any object moving from the beginning is considered as t is equal to 0 and is asking at t is equal to 5 seconds what is its position. Position means the displacement, the distance it is covered. It is a velocity time graph. From any graph, we need to understand two things. First of all, slope and area under the graph. If you are given a velocity time graph and asking the position, you should immediately understand that considering area under the graph, you will get the displacement from this VT graph. So that is how we proceed. So what is the area under the graph? From 0 to 5 seconds. This is 0 and here the 5-second mark is here. So between t is equal to 0 and 5, the graph is like this. From here to here, 0 to 2 seconds, 2 to 3 seconds, 3 to 4 seconds, and here from 4 to 5 seconds. So the area under the graph is from here to here, from this 0 position to this position at the 5th second. So the area, that means area under this graph. How we get this area? Half into base into height, or you can take half of the area of this square. So in that case, the displacement done, that means position after 5 seconds, can be calculated as half into, that is base, that is 2 seconds, into height, this is also 2, plus the total area under this graph from 0 to 5. How to get this area? This is 2, this is 2. So from 0 to 2, this is 2, this is 2, and the area of the square is length into breadth, or a square we can call it as. This is 2 into 2. So how is the area of this particular rectangle is taken? Length into breadth. Length is, this is 1, 2, 3, and the breadth, that is time, is 1 second. So the velocity is 0 to 3, 3 into 1, plus here we take plus 3 into 1. So here we will get the displacement. Here this is 2 plus 4 plus 3. So 6 plus 3, 9 meters. So answer is D. This is how we take the displacement, that means position after t is equal to, at t is equal to 5 seconds. There is another method, we can also approach that method. I will tell you what is the second method. You can calculate the displacement from here to here. That means if you can take this equation as s is equal to ut plus half at square, and u is 0 here, t is 2 seconds. What is the acceleration? Here you need to get the acceleration. Acceleration is equal to change in velocity by time. Velocity, this means 0 to 2, it has increased. 2 minus 0 by 2, that is 1 meters per second square. You put a as 1, that means 0 into 2 into half into a. Acceleration has come as 1 into time 2 square. I am calculating the displacement from here to here using the equation of motion, this one. Now how we will get 2 into 2? This is cancelled, and this is what you got, t square. I think this is plus, yes, plus, and 2 into 1 t square. So here 2 plus this is 2, that is equal to 4. So in this way you calculate the displacement from here to here and here to here. So you will get the total displacement. This is the second method you can follow in this problem. Here next we see the second problem. Find the average velocity when a particle completes a circle of radius 1 meter in 10 seconds. Here we know the average velocity, V average, formula is equal to total displacement by total time. Whenever you are taking the average, you considering the total value with respect to the total time. So here the total displacement by total time. So in this case, actually the object is moving in a circular path, completes one circle of radius 1 meters. So a particle starts from A in a circular path of radius 1 meter. So here what is the displacement? Logically the displacement is nothing but the shortest distance between the initial point and the final point. The initial point is A and again completes one circle, ending point is also A. Here the displacement is 0 in this case. So here the average velocity is 0 because the displacement is 0. 0 by time is equal to 0. So answer is D. It is a logical problem on the displacement. Here we will see the third problem. See, the position of a particle as a function of time t is given by x of t is equal to at plus bt square minus ct cube, where a, b, c are constants. When the particle attains zero acceleration, then its velocity will be. See here, the position is given as a function of time. That means with time, the position is varying. How it is varying? This is the equation. According to this equation, the position is varying. If you take time is equal to 0 and it is starting point, you will get the displacement according to this equation. So in these cases we know that the velocity is asking, then its velocity will be, where if the acceleration is 0, then what is its velocity? First of all, we have the information about displacement, an equation which is given for displacement. So we know that rate of change of displacement is nothing but velocity. So here we will differentiate this equation to get the velocity with respect to time on both sides. So if you differentiate on both sides, this will be dx by dt is equal to differentiation of at will become a plus this will become 2bt, this is 3ct square. So what I have done, I have differentiated the equation 1 on both sides with respect to time. So rate of change of displacement dx by dt we know is nothing but velocity. So velocity is equal to, this is equal to velocity. Okay, now we got the velocity equation also. Now what is the condition here? At the moment where the particle attains zero acceleration. Now we need to get the equation what is for acceleration. We know that the rate of change of velocity, that means dv by dt is nothing but acceleration. So here we will differentiate this equation 2 with respect to time on both sides. So differentiating this equation, we will get this constant. Differentiation of any constant is 0 plus this is 2b, this is equal to 6ct. 6ct. So here the condition is acceleration is 0. At acceleration is 0. So this is equal to 0. Now from this what we can take, 2b is equal to 6ct, and this implies t is equal to 2b by 6c, that is equal to b by 3c. What is the time we have got? B by 3c. So at the acceleration is 0, at the time b by 3c. So we have the time at which the acceleration is 0. This time is substituted in the velocity equation. Then you will get the velocity when the particle is having 0 acceleration. So substitute this t is equal to b by 3c in this equation. So we will substitute, this equation will become a. So there is no time here. In the first term we will take it as a only, plus 2bt. So here substitute t with b by 3c minus 3ct square. So 3c into what is t? b by 3c whole square. Okay. Now here from this will become a plus here 2b square. Observe this, 2b square by 3c minus here c 3c, this 3c will be getting cancelled. So what you can write? Wait. Here one 3c will be getting cancelled. So we get here b square by 3c. Okay, we got b square by 3c. Now what is the final answer? That we will come as velocity is equal to a. If you subtract 2b 3c by b square minus 3c, this term will become a plus b square by 3c. That is the final answer. The velocity at which the acceleration is 0 is equal to a plus b square by 3c. The answer is C. Here we see the fourth problem. A particle starts from origin O from the rest and moves with a uniform acceleration along the positive x-axis. Identify all figures that correctly represent the motion qualitatively. So the representation of motion is only by means of the logic, not any taking any numericals. That is the meaning of qualitatively. Here the answers are 4. Which is the best option that suits the motion, represents the motion? Identify all figures. You need to identify all figures. See here the options are given as the answers. The option is, here it may be A comma B, and the option 2 is B comma C. Option C is A comma B comma C, and option D is A comma B comma D. So option D is A comma B comma D. Out of these four options, we need to choose the answer. So which are exactly representing the given data. First of all, we will take this one, whether it is representing this picture. The acceleration is constant here. That means uniform acceleration. So okay, the figure A is representing this motion. Okay, we can take A as done. Next, second one, velocity time. Here you can see the slope of this graph is constant. So the slope, velocity by time. Slope is nothing but tan theta. So opposite side, if you consider this is also velocity, opposite side by adjacent side is always constant with this graph. So here the velocity is increasing as per the increasing acceleration. So this graph is also suitable for this kind of motion. And what about C? Here see, the displacement is increasing up to some time and again it is constant. It is not possible because it is moving with uniform acceleration, so the velocity will be keep on increasing uniformly. So, and displacement will also increases. The velocity is increased, displacement will also increase. It cannot be a constant after some time, so this is ruled out. So here option D. And here see, the displacement time graph looks like a parabola, means if we take the displacement equation, x is equal to ut plus half a t square, and here the particle starts from rest, that means x is equal to u becomes 0, half a t square. So this implies x proportional to t square. So figure D will also represent this motion. That means displacement is proportional to square of the time. So the graph will be a parabola. So these three options A, B, D representing this motion, but C is not. So the answer here is option D. A, B, D. Here we will see the fifth problem. An object is moving along the path OABO. Here it is shown in the figure. Starting from O, A to B, B to O with constant speed. Then there are four options given. The question is, choose the right option. So what are the options we will see? The acceleration of the object while moving along two paths. See, moving along the path OABO is 0. Here along the path OABO, the entire path, for the entire path OABO is saying the acceleration of the object is 0. That means there is no acceleration. And option B, is it correct? We will see. Check the all other options and we will decide which is correct. The acceleration along the path OA and BO is 0. The acceleration along the path OA and BO, it is the acceleration is 0. Here we can say it is correct because along OA you can see there is no direction change and the speed is constant. Okay, the speed is constant and the direction is also remains same, constant. There is no change of direction. So we can say along OA and BO the acceleration is 0. Okay, what about the first option? The acceleration of object while moving along the path OA BO is 0. We will see that after this option. There must be some acceleration along the path AB. There must be some acceleration. See, here it is said it is uniform constant speed, but he is saying along the path AB there must be an acceleration. Is it possible? Yes, because along the path AB, if you observe, even though the speed is constant, the direction of the object, the direction of the path is changing. Speed is constant along AB, but the direction is changing. So whenever there is a change in direction, there must be an acceleration. That means it is a curved path. So there must be an acceleration, and along the curve, if an object is moving, the acceleration we can call it as centripetal acceleration. So the option C is also correct, option B is also correct. So this option A is not correct, because along all the path is saying acceleration is 0, but we are saying along AB acceleration will be there. So option D is our answer. Answer is option D. Both B and C are correct. Okay, in the next video we will see some more JEE problems on motion in a straight line.